Section 3.3, we're going to be focusing on just solving systems of linear equations, applications problems. So this is everybody's favorite because application problem is just code word for word problems. And we all know how much we love word problems. So um, nonetheless, the idea here is what is the new material? What are you supposed to be learning in here? And the answer to that question is nothing. You're supposed to already know everything that's in this section. You're supposed to just be putting together the methods we have for solving systems of linear equations. So that's either elimination, substitution, method 3, which would be graphing, or the one that I would really hope you would practice the most because it's new, not review, is the Gauss-Jordan. And of course, you can use your calculator if you don't need to practice the method. If you have that down, if you have the pattern down, just use the calculator on the big messy problems. So this is basically just practice. The section is just practice. But I will highly recommend anytime we hit word problems, these are always the sections that are really hard for students. So start early. Make sure any word problem section start early. Ask questions. Give me time to respond to you. Okay, so here we go. If you feel confident, pause the video, give it a shot. Here we are. The admission fee at a local zoo is $1.50 for children and $6 for adults. On a certain day, 3,000 people enter the zoo and $10,350 is collected. How many children and how many adults attended? So, as I told you guys in a previous section, I always recommend first define your variables, and that can usually be found in the last sentence. What is the thing we are looking for? So we're going to have C for the number of children, and maybe A for number of adults. Okay, so for variables C and A for represent number of children and number of adults attending, then what we need to do is look through the problem for things that relate those two variables, things that relate children and adults. And the way this problem is written, it's actually relatively simple to see because they're built together. They're in the same sentence. The admission fee is $1.50 for children and $6 for adults. So therefore, we have a dollars relationship. And we see that there's a total of $10,350 collected. So our money equation would be $1.50 times C. So $1.50 per ticket times the number of tickets, or $1.50 per child times the number of children, plus the adults is $6 times the number of adults, and those together should add up to make $10,350. So we have a dollar relationship. Now, since we have two variables, we need two equations. Let's go back and look for another one. Oh, look, we have 3,000 people enter the zoo. So what does that mean to us? Well, the number of children plus the number of adults should equal 3,000 because each of them count as a people. So now we have our matrix. So all we're going to do here is say 1.50 plus 6.00. So not plus, matrix. There we go. 1.50, 6.00, 10,350. And of course, you don't need to have all the decimals if you don't want them. Just don't lose sight of what they mean, because meaning is very important. So now you could use the $1.50 and use that number to get the one below it down to a 0, right? But let's just use the calculator. Might as well. It's always so much easier. Okay, so now we're going to go into our matrix. We're going to go edit. This is a 2 by 3. And what were our numbers? I'll move this to this side. 1.5, 6, 10, 3, 5, 0. Then down here it is a 1, and 3,000. So now double check your numbers, because there's nothing worse than thinking you did it right and you just typoed, you missed a number, you missed a 0, something goofy happened. Oops, that's not what I wanted. There we go. So now I'm just going to hit enter for reduced echelon form, and it spits out a nice, beautiful number for us. So what does this mean? Here we go. I'm going to take this and pop this into into my notes right here. So how do I read this? Well, this is telling me, now, don't forget what each column stood for. This is why sometimes it's good to label them. So the first column was C, the second column was A. So therefore, this means C equals 1,700, A equals 1,300. So there were 1,700 children and 1,300 adults. And that makes sense. Those numbers and those units fit. It would, if you got some kind of weird, crazy decimal here of 1007.376, you'd have to really stop and think, did I make a mistake? Is there something I need to state about this value? Because it's not possible to have 1,700.4 children come in, right? It has to be a whole number. So, but it's good. We got whole numbers. It makes sense. It's fantastic. So last but not least, I always recommend when you finish a problem, always go back and read and make sure you answer the question that was being asked. So they're saying how many children and adults attended? 1,700 children, 1,300 adults. Perfect. Okay. If they had asked for something else like money or revenue or whatever, then you have to go back and just relook. But that one worked out fine. Okay, not all problems will be so straightforward. Sometimes we try to hide information, or you have to use a little bit of common logic or thinking. So this one is kind of goofy. It's not really so much of a business application, but everybody should hopefully know a little bit about chickens and a little bit about pigs. So let's see here. A farmer saw some chickens and pigs in a field. He counted 47 heads and 150 legs. Determine exactly how many chickens and pigs he saw. All right, so step one, determine your variables. What are we asking for? C equals number of chickens, and P equals number of pigs. So now that we have our variables, let's look for two things that relate them. Let's look for something that relates them. Well, heads. How many heads does a chicken have? One. Right? And how many heads does a pig have? One. So the number of chickens plus the number of pigs should equal 47. Second, legs. All right, let's talk about a legs equation. We know there's a total of 150 legs, so this thing should equal 150. How many legs does a chicken have? Well, each chicken has 2 legs, so I take the number of chickens, multiply by 2. Each pig has 4 legs, so I take the number of pigs, multiply by 4. Once again, logic says the answers to this should be a nice whole number because you can't have half a pig or half a chicken. So there we go. And if you wanted to, you could notice that this is divisible by 2, right? So you could take row 2 and divide it by 2. And what would that result in? 1, 2, 75. And that would be absolutely fine to go ahead and do that. And you could solve your problem now. And we'll do that one in the calculator. Why not? We're going to go over here, edit. And it's a 2 by 3 once again. 1, 1, 47, and 1, 2, 75. All right, I'm just going to hit enter so it redoes reduce echelon form. And what do we get? 1, 0, 19, 0, 1, 28. So what does that mean? Interpret your answer. Let's see. Don't forget your columns. This was C, this was P. So therefore there were 19 chickens and 28 pigs. Now, is it okay to jump straight from here to here? Absolutely. As long as you're writing your answer out and you're fully interpreting it, that's perfect. You don't have to show me the C equals 19 and P equals 28. Now, if you want to, fine. And especially because if you make some kind of mistake, it gives me that in-between step to say, yeah, they knew what they were doing. They just did something silly. But nonetheless. Okay, so what have you learned in this section? Yeah, not much? Okay, word problem practice. There is one more problem that I'm going to do, but I'm going to do that in another video. So we'll see you in the next video.